Hi everyone, this is Peric from P2 Design. This video is an introduction to space switching. It's a super powerful technique that can be used for both characters or motion design. It allows you to generate additional animation by sourcing the base motion of your character, for example. With this method, I was able to get from this basic walk cycle to this super detailed walk cycle in a few minutes. This lesson is a free sample from my new animation course, Alive, that is now available. You will find the link in the description below. Enjoy! In this video, we are going to use the constraint we've just seen before to animate the different part of the robot character using the base motion we have created before. To do so, we will use a method called space switching. This is an often overlooked technique, but it is so powerful. I've been introduced to this technique and learned a lot of things through the Animation Sherpa course by Richard Lico. He's one of the coolest person I know, and beyond that, he's one of the best animator in the game industry. I will just show you the very basic of space switching, but if you enjoy it and get comfortable with this animation course, I truly advise you to take his animation course afterward. So let's start with a simple up and down animation. What I'd like to do is make bone B react to bone A, having a bit of overlapping animation. And instead of doing it by hand as we did for the bouncing ball or our squirrel character, we will use constraints. The idea is to source the motion of bone B in world space and slightly offset it in time. Don't worry, this will make sense in a few seconds. Let's select bone B, press Shift S and snap the cursor to it. Let's switch to object mode and add an empty. We want the empty to behave exactly as bone B. To do so, I will select the empty, go to the constraint panel, add a copy location panel, and source the armature. Then I will select the bone B. Now our empty is following the bone B in space. It is copying its location in world space, and I can no longer move it. But we don't have any animation information we can play with. The graph editor is empty. So what we need to do is to convert the current motion of the empty that is due to the constraint in an actual animation. And we can do this through baking. To do so, let's just have our empty selected, press F3 and search for bake. We will choose the first one, Object Animation, Bake Action. A bake action panel will open. Here we can set the length of the action we want to bake from frame 0 to frame 25. I always used visual keying so that I'm sure that all constraints are applied when writing the action, and we want to get rid of the constraint, so I will enable clear constraint. I won't use overwrite current action since our empty don't have any action yet. As I press OK, Blender will get rid of the constraint, and I do now have an action built into my graph editor. If I play the animation, I can see that the empty is kind of following bone B, but it's no longer constrained to it. Its animation is just similar as bone B. I will clean up the channel I don't need and keep the Z location only. Now we have data we can edit. We can offset the keyframe or edit them. And since those animation data are assigned to a single object, they are using world space. While bone B has no motion in its local space, it is not animated, it's just following bone A. Our empty does have an animation, but it is visually doing exactly the same thing as bone B. Now to see the power of space switching, let's select our empty. In the curve, press Shift E and add a cyclic modifier. If I now select all the keys, press G and X and offset them a bit in time, you can see that now the empty seems to have a follow-through animation compared to bone A. So if I now select my armature, go into pose mode, select bone B, we can access the bone constraint. So be very careful. We are not constraining the armature object, but the bone. So we need to go into the bone constraint, not the object constraint. From there, we can add a copy location constraint and then source the empty. Now bone B will follow the motion or the location of the empty. From there, we can press F3 and search for bake. Or in my case, I've added the bake action functionality to my quick favorite, so I can press the Q key to access it. I will use the same option, visual keying and clear constraint, and I will add overwrite current action. Now bone B is no longer a constraint, but it's following the same motion as the empty. We can now get rid of the empty and check the curves of bone B. All channels have been written, but only the Z-axis channel is interesting for us. You have just performed your first space switching exercise. Let's now see what we can do with copy rotation. In the example file, you will find a second collection with the copy rotation example. It's a simple chain of 3 bones, with bone A being animated. It's a simple back and forth rotation on its x-axis. Bone B and C are simple children without any animation. Let's go back into object mode and add 2 empties. For the sake of presentation, I will add on the first empty a copy transform from bone B. Go to the constraint, add the copy transform, source the second armature and bone B. Now our empty is snapped onto bone B. For the second empty, I will add a simple copy rotation and source the same armature and bone C. The first empty is now copying both the location and the rotation of bone B, but in the end what is interesting for us is only the rotation. If I was to isolate the motion of the first empty that is also copying the location, he will be rotating as the one above. But it can be a bit confusing to see only the rotation of the empty whenever the bones are currently childs of another one, and their location is also changing. But in this case, we will only affect their rotation. So I will switch to a simple copy rotation and source bone B, and I will select both empty, press my Q shortcut, and bake the action. Now both the empty have lost their constraint, but we have animation data. So we can now use those 2 empties to constrain bone B and bone C. But first, let's make sure that we have all the curves selected for both empties. Press Shift E and make cycle. Now let's select the armature, go into pose mode, select bone B, go to the constraint panel, add a copy rotation constraint and source the first empty. Big mistake here, we've added the constraint onto the object. As explained before, we need to use bone constraint. So let's add a copy rotation, source the first empty. Select bone C, add a new constraint and source the second empty. From there, when we play the animation, nothing changed, since those 2 bones are copying the rotation of something that was copying their rotation previously. But if I now offset the curve of the first empty by 1 or 2 frames, you can see the chain of bones changing. And if I now also offset the second empty by 3 or 4 frames, I will get an overlapping motion of my whole chain. So the idea is to offset by 1 or 2 frames the first empty, then the next one by 1 or 2 additional frames. So 3 to 4 frames. And we get our overlapping motion for free. From there, we can select the armature, go back into pose mode, select both constraint bone, and bake the action and choose overwrite current action. And we can get rid of the empties and we have our animation done. Let's see a first example with aim space. I have this sweeping motion, but I don't want B and C to get through this plane. To create the tracking constraint, we need first to add a couple of empties. And then to those empties, we will add a copy transform so that they follow each bone. So I will source bone B for the first one and bone C for the second one. This way, both empties are perfectly aligned with each of their targets. Now, to be able to get rid of the constraint but keep those transforms, we can press Ctrl A and choose Visual Transform. I will do this for both empty and get rid of their constraint. But the cool thing is that now their transform channel has the same transformation as bone B and bone C, but in world space. So if I go into my empties properties editor and switch to arrows as a way to display them, you will see that they are now aligned with bone B and bone C. They are sharing both the same orientation and position in world space. We now need to offset them, so I will switch the pivot point to local with both of them selected, press G and move them on the Y-axis, so that they are still aligned with bone B and C, but they are further away on their local Y-axis. Now for them to follow the motion of bone B and C, I need to make them become child of those bones. And we can use a new constraint that is the child of constraint. It's a very handy constraint that will make the owner behave as if it was a child of the target. As a target, let's source the armature and then bone B. We can see that the empty got offset. Just click Set Inverse to reset its position. And let's repeat the process with bone C and the second empty. Source the armature, choose bone C and click Set Inverse. Now, if we play our animation, we can see both those empties following both bones. Let's select both empties and bake the action or bake the animation. As before, whenever we are baking the action, we can choose to remove the constraint and we can see our empties still following the motion, but now they do have animation data. We don't need any rotation or scale here, so we can get rid of the rotation and scale curve. You don't need to do it, it's just to keep the graph editor cleaner. Now go back on the armature in pose mode, go to the bones constraint, select dumped track constraint and source the first empty. Then repeat the process with bone C, add a dumped track constraint and source the second empty. When we play the animation as usual, nothing special happened, but if I select the first empty, press Shift E to make all the curves cyclic, and then offset them by 1 or 2 frames, we can see our bone chain offsetted. And if I repeat the process with the second empty, but offset it by 2 frames, now you can see the chain animated with a bit of overlap. It seems that the make cycle function didn't work on this curve, so I will fix this. And now, if I want my chain to avoid getting through or clipping with the plane we have created, I can simply work on the curves or the animation of the different empties. So I will select the first empty and work on its Z location curve. I will try to spot the key where it goes under the ground, and I will select the key and offset it a bit on the Y-axis in the graph editor so that it gets a little up. I will then go further whenever it's leaving the ground, and I will duplicate the frame I've just adjusted on top of this one. Those two keys represent our ground level, and I can get rid of any keys that goes under this level. I can now repeat the process with the second empty, isolate the C location curve, spot the moment where it goes underground, then align its position with the ground, go a little further, duplicate the keyframe, and get rid of any keys that are under this level. And when I play the animation now, it seems that this whipping motion is stuck to the ground. Then, as usual, we can go back onto our bone chain and bake the action. And if there are any glitches in the animation, you can remove a couple of frames to get a smoother transition. Using aim space is a super powerful workflow. Don't worry if you get a bit lost at first, we will repeat this process a lot of time on the robot and you will get very familiar with it. Now in the last example, we will see how we can combine both the copy location or location switch with this aim space. To do so, I've created another armature with another animation. It's a simple up and down motion with a little bounce. So it's pretty close to what we have between the body and the cannon of our robot. We will start with the location offset. With my bone B selected, I will press Shift S to snap the cursor to it and add an empty. To this empty, I will add a copy location constraint, sourcing the armature and the bone B. Now the empty is following the motion of the bone B in world space. I can press my Q key to get to my quick favorite and bake the action. I can get rid of all the curve but the Z location curve, press Shift E and add a cyclic modifier. From there I can slightly offset the curve in time by 1 or 2 frames to get a nice overlapping motion. I will then select back my armature, go into pose mode, go into the bone constraint, add a copy location, source the empty, and now bone B get this overlapping motion. I can press Q and bake the action. I won't delete the empty because we will need it to currently create the aim space constraint. So the first thing to do is to align the empty on the bone B. So let's add a copy transform constraint to the empty and source as a target the bone B. Let's press Ctrl A and apply the visual transform. We can get rid of the copy transform constraint, and if we want, we can go to the empty option and switch to arrows to see that it is oriented the same way as the bone. I will offset it along its local y-axis. And now we need to add a child of constraint to it, sourcing the bone B, click set inverse to reset its position, and it's now following the motion of bone B as if it was a child of it. Let's bake this animation. We can cleave the curve if we want, getting rid of the curve that doesn't have any animation, then press Shift E and make the current curve cyclic. Then we can use it to constrain the bone B using a dumped track constraint. If we now select back the empty and offset its curve in time, we will have a bit of follow-through animation in the rotation. So we have offsetted the motion of the bone B using a location offset and now also using a dumped track constraint. The cool thing about the damped track constraint is that it's very easy to smooth a curve. If, for example, I don't want that much bounce onto my bone B and I want a smoother transition, as if it was very heavy, I can get rid of some keyframes, offset a bit the lower key, and it will still follow the original motion of the bone B location-wise. So the base of the bone still have a pretty crispy and sharp bounce, while its tip that is pointing toward the target or the empty get a smoother motion. The last thing we haven't seen regarding any constraint is that we can reduce the influence of the constraint if I want to reduce the amplitude of the rotation of the bone B. It would have worked the same with any other influence, such as the location constraint. The bounce would be the same, but with a lower amplitude. From there, we can bake the current action onto the bone B. Don't worry if you're a bit lost at first, just try to redo the exercise you've just seen. We will repeat this a lot through this chapter, so you will get familiar with this technique very fast. Learning those techniques will become a huge time saver for you later in the course. To summarize, we have seen that we can use constraint and animation baking to source data from a specific motion and transfer them onto another bone or another object. We can use copy location and copy rotation to create nice follow-through animation with ease. We can have even more control upon rotation of the target using tracking constraint such as dump track constraint. We can use multiple constraints to create complex mechanism in a few clicks. And finally, we can use the influence of the different constraints to add more or less amplitude to the motion we are creating.